Let's now learn what is a Kubernetes service, why do you need it, and how does it work. Let's assume this is a Kubernetes cluster where you have deployed an application. It's a web server application running as replicated instances created using some sort of a controller. Now, this application needs to be accessed using two entities or from two entities. One is another service running inside the cluster, and second is the user who's outside, sitting outside the Kubernetes environment, and the user wants to access this front-facing web application using his or her browser. Let's now look at how to make this possible. And we'll begin with the application which is running inside the same cluster, and this application is the one which is going to access the web servers. Now let's assume that there are 4 instances of the web server. Each of this is running as a pod, and each of the pod has an IP address to it. Now we know that the pod deployments are immutable. What that means is every time a new version of the application is deployed, the IP address of the pod is going to change because the pod itself gets redeployed and it gets recreated. The existing one goes away, the new one comes up. When that happens, the IP address of this pod is going to change. And in such scenarios, for the application running inside this cluster to keep track of each of these pods and their IP addresses and configuring them somewhere inside the application configurations here is quite a task. To make this easy, Kubernetes offers an entity called as a service. And the way it works is this. You could think of Kubernetes service as a load balancer. Let's say this application is called as a web, so you will create a service with the name as web. And this service is a logical entity and it provides a common endpoint. It has an IP address, so the service itself will have some IP address provided inside the cluster. So any other application that needs to connect to these web servers will now go through this service. And then the service will distribute the traffic across the available set of pods. So you can look at service as a load balancer of sorts. Now, one thing which is quite interesting is how does this service know which pods to send the traffic to? And this is where Kubernetes' metadata plays a role of itself. And the way it would work is you typically label your pods with something. You label your pods with your application name and role and so on and so forth. So all you have to do is label your pods with some tags. Let's say role as web, and the tier is front end, and so on. And then when service needs to decide where to send the traffic to, it has a concept of selectors. And this is how it works in replication controllers or any other controllers as well. So how do the controllers decide which pods to monitor? Depends on their tags or the labels. Similarly, service is going to have a selector and it's going to select from the available set of pods using some sort of a search criteria. And typical search criteria might look like, hey, I want to send the traffic to any pod which has this label called as role web. And this is how service decides to send traffic to these pods, available set of pods. And you might have hundreds of pods, so service is gonna pick the pods with the specific set of labels. So metadata in Kubernetes, labels in specific are extremely important. Now once you have the service created, it offers the load balancer. It also offers as an endpoint so that the application that you have inside the cluster can detect that service and point to it using the IP address, or even better is the name, because each of the service is been associated with a DNS as well. So there is a DNS server running inside the cluster, and whenever you create a service, whatever the name of the service that you decide is what is added as a DNS name. So your application is going to connect to this web server as using, maybe if it has a connection string, it would just use host is equal to web. And that web will get translated, that DNS, the name will get translated into one of the IP addresses based on how the selection criteria is, right? So you have to configure the service, give it a name, and then start using that name inside the cluster from any other application. That's how you access it from inside the cluster. Now, the next part about our discussion was the second entity that needs to access this service could be a user who's gonna come from outside the Kubernetes environment. By default, the access to any application or the service inside the cluster, even if you create a service or even if you just have pods, it is limited to the cluster only. It is not available from outside. You have to create a specific type of service or a specific way to expose it outside. There are 4 different ways that you could expose your service outside. 2 being the types of services, namely node port and load balancer. 1 is a property of a service. This is part of the service spec called as external IPs. And the 4th is an ingress controller. Ingress controller is not really a service or any spec of a service or a type of service. It's a different entity altogether which allows you to run an actual application level load balancer, a layer 7 load balancer such as Nginx, kube-proxy, traffic, ambassador, and then there are many. And this is an application which runs inside the cluster, and it allows you to expose your app, service outside using a layer 7 application load balancer. Everything else, including the node port, the load balancer, and the external IPs, is a layer 4 type of a service, which means it works at the TCP IP layer versus the ingress controller works at the layer 7. Let's also look at the 2 types of services given here, node port and load balancer. The way node port works is it picks up a port in the range of 30,000 and 32767. So there's a limit only. So it cannot use any other port. It will only use this port in the range. And what is interesting is it will expose this port on every single node, the same port. Let's say you have exposed this service on port 30,000. So what is going to happen is the 30,000 port will remain reserved on every node in the cluster. And no matter which node the traffic goes to, it will automatically point to the pod or redirect that request to the pod, even if the pod does not exist locally. And the reason why it has been created this way is to ensure that you don't have to worry about which node to send the traffic to. You can just pick any node, send the traffic to it, and it will get delivered. That's a guarantee. Node port works on any type of environment. It could be cloud, it could be data center, it doesn't matter, it just works fine. Load balancer, on the other hand, is another type of a service which works only in a managed environment such as cloud. So it has that limitation. You cannot use load balancer service on your, let's say, a typical data center environment. And the reason for this is the type of load service load balancer, it actually works with the managed load balancers on, let's say, available on cloud. For example, if you create a load balancer of type of a service on AWS cloud, it will automatically create the ELB. ELB is a layer 4 network load balancer on AWS cloud. And not only it will create the load balancer, it will also add the listeners, it will configure it to send it to the nodes, and it will do all the configuration which is needed. And that's all seamless and automatic. And this is the beauty about Kubernetes. And this is why Kubernetes is so sophisticated, because it knows how to talk to your cloud, how to talk to your cloud for creating volumes also. So not only load balancer, it also integrates with different storage systems and so on and so forth. So Kubernetes comes with all of this code available out of the box. That's amazing about Kubernetes, and that's why it is so sophisticated. So load balancer works only on cloud, node port works everywhere. External IPs is how you can expose your application as well, and that is not a type of a service, but it is a part of a service spec, the properties of a service. And the way external IPs work is you can decide which nodes you want to expose your application on, and that too on a service port. In case of node port, it picks up from 30,000 to 3276 range. But in a case of external IPs, it actually points to or uses the service port and exposes it on a specific nodes. You can also use external IPs to point to your hardware load balancer. So if you're running this in a data center, and if you have your existing load balancers configured, and if you want to configure traffic to be accepted from that load balancer, you can also use external IPs there. There are two more service types that you should know about. And the default type of a service is actually called as a cluster IP. If you have a service of type cluster IP, what happens is you do not have a way to access that service from outside automatically. The only applications and the services that can access the service of type cluster IP are the internal applications or internal services. For example, this particular application, which is running inside the Kubernetes, can access the service created with cluster IP using its IP or the DNS associated with it. By default, it is not exposed or made available outside. You can do that though using the external IPs as a configuration or using the ingress controller. And cluster IP is the default type of a service. What that means is, even if you do not define the type of service in your service spec, it is set to cluster IP by default. The fourth and the last type of service is called as external name. Now this can create some confusion because you might think external name can be used to access your service from outside. It's actually the other way around. I'll explain it with an example. Let's say you have a database in a managed environment such as cloud. For example, you have set up a database using AWS's managed service called as RDS. Now this database will have a CNAME or an IP address associated with it, typically a CNAME. Now what you do with external name is create an alias internally so that you create a service by name. Let's say internally it is called as DB, and then that DB actually points to the managed database that you have created on RDS with its CNAME. So it creates sort of an alias. Why this is useful and when this is useful is, let's say you have an application running inside a Kubernetes which has connection string defined as DB. That's the host name. Now, you don't want to update that connection string every time, and you may have a database running inside the cluster Kubernetes environment itself in dev environment. But in production, it is outside and you're pointing to RDS. So you can accommodate both of these situations. You can create a service, a normal service with cluster IP type, and point to your database in dev, versus in production, your name, the service is available inside the cluster with the name DB, and that actually points to the managed environment which is running outside the Kubernetes. In such cases, external names are useful. This is also a service of type headless. Why it is called as a headless service is because it does not rely on the labels and selectors to find the pods running inside the cluster. In this case, it is using external name. There is another type of a headless service where you do not define the cluster IP and you do not define the selectors and labels, but you point to specific endpoint by providing an endpoint object manually. So you can create an endpoint object with a list of IP addresses and endpoints, and then service will point to those endpoints instead of the ones selected using the concept of labels and selectors. And that pretty much covers all the concepts that you must know about the services.